Okay, so we already went through these rules, okay? So I'm going to talk about them for like 2 minutes, and that's all I'm going to do. So remember, the first rule is log base a of 1 is 0. So what you have to remember is log base 8 of 1 is 0, log base 23 of 1 is 0, log base 143 of 1 is a 0. It's just something you have to remember, okay? The second rule is log base a of a is a 1. The examples I gave, log base 11 of 11 is 1, 42 of 42, 572 of 572. If those match, it's 1. This third rule right here, you totally don't even have to memorize it, you guys. So you pull the n down, you get n times log base a of a. Log base a of a is a 1. 1 times n is an n. So there's really nothing to remember, just to pull down the exponent. And it just incorporates that rule right there in it is all. Okay? Okay, this one right here. So if this and that both match, like 7 raised to the log base 7 of 2r, then your answer is 2r. And then the last rule we talked about is if you have the log of x equals the log of 17, then x must be 17. Okay? Okay, let's go ahead with number 1. Stick right with me, okay? Freeze for 2 seconds and let me ask you a question. Who says, I feel like so far I'm really understanding these logs and I'm doing fine. Do me a big raise. Okay. Oh, and even noise comes with it. That must be good, right? Okay, that's good. You want to stay that way. We're going to continue to do logs right up until the test. And then we're done with logs. So we've got like another, week and a half of logs. Okay, so question A. Do you see that exponent? Pull it down in front. So you have x times log base 3 of 3. Everybody in the room, all 35 of you, what is log base 3 of 3? 1. And you're multiplying by x, so 1 times x is x. That's it. Okay, everybody freeze right here for 2 seconds. Don't write, just listen. I'm going to say the same thing I've said like 7 times. So here comes number 8. If a person is confused about logs, it's because, what's the cause? They don't know the rules. They don't know the rules. So all this manipulation we're doing right now all connects back to a rule. But if you don't know the rule, you can't do the manipulation. I'm telling you, know the rules and it's a home run. Okay, question B, there's not even any work to show. Try not to look at the rules as we have this discussion. Try to make yourself remember the rules. What's the answer to B? 7. It's just 7. Yeah. Remember, if this 5 is raised to the log of the same base, then that other number is your answer. So it's just 7. Okay. You guys look at that ln. Some people do this, like ln base e of 4 or something like that. Does an ln have a base, everybody? No, it doesn't have a base. So that person's confused. But is an ln a log? Tell me that. Yeah. Yes, it is. It's log base e. So let's write down log base e of e to the 3x. Now, do you really have to take that step if you know in your head that ln is log base e? You don't. Okay? So take the 3x, pull it down in front, so you have 3x times log base e of e. Guys, what's log base e of e? 1. What's 1 times 3x? 3x. Done. Just a bunch of rules and a bunch of manipulation. That's all it is. Okay? Okay. Here's what I notice the second I look at D. I see the ln, which I know is log base e, and then I see the e. So then I say to myself, they're trying to get me to write it as log base e of e. I know they are, okay? But the e to the 4th can't be on the bottom. I got to pull it up to the same level. So everybody write log base e to the 4th comes up and becomes an e to the -4. So I did 2 things. I wrote ln as log base e, and I pull my e to the 4th up. Now I pull my -4 in front, so it's a -4 times log base e of e. Log base e of e is a 1. 1 times -4 is a -4. Who says I totally get this? Raise your hand. Let me see. Okay, great. You don't have to write it as log base e. I always write it as log base e because I think it's easier for you to follow me if I write it like that. Okay? So anyway, okay, let's do e. I bet some of you know the answer right now. What's the answer? It's 3. Everybody write e raised to the log base e of 3. Do you really have to write that line? No, I'm just trying to show you. You have an e raised to the log of the same thing, e, so your answer is right there. It's just a 3. That's it. Okay? All right. More easy rules, more easy problems. What's the answer to this, guys? X must be, talk to me, 17. The bases are the same. You know, it's got to be the same. It's just one of those rules. Okay? Log base 17 of 17. Everybody tell me what that is. 1. Everybody write X equals 1. That's it. Okay? All right. Grab your calculators. Look at these 5 problems. Okay? Just freeze and look right here before we start doing this. They all are different. Every single one of those is different. Right? Okay. Now grab your calculator and go log 32. Close it off. Hit enter. Let's write it to like 3 digits, 1.505. Let's do the next one. Log 16, close it off, plus log 2, close it off, enter. I got exactly the same thing. So they look different, but they're equal to each other. Let's do the next one. Log 4, close it off, plus log 4, close it off, plus log 2, close it off, enter. Same exact thing, 1.505. Unbelievable, right? Everybody go 5, log 2, close it off, hit enter, same thing. Last one, log 64, close it off, minus log 2, close it off, enter, exactly the same thing. Okay, so here's what I want to say to you. You can manipulate every single one of those equations using the rules, and they end up just coming back to the same thing. Let me show you what I'm talking about. Just look and freeze for 2 seconds. These right here are added. When I condense, I multiply. So that's going to be the log of 16 times 2 is 32. Well, now it matches the first one. Let's do this one. When you add, you multiply. So it's going to be the log of 4 times 2, which is, again, the log of 32. I'm going to keep going. This one right here, pull your 5 up. That's the log of 2 to the 5th. What's that? Log of 32. Look at this guy. Condense into one log. The negative tells you to divide. The 64 goes on the top. That's going to be the log of 32. They're all the log of 32. You just have to mess with them using the rules. Who says I understand that? Raise your hand. Okay, good. Okay, more rules. Okay, hook them together. And tell yourself that I have to memorize these. Okay? On the left, put condense. On the right, put expand. And then put an equal sign in between those for all of those. Okay? You have to understand that condense, you guys know condense means squished in, right? Draw an arrow to condense. And I want you to write this down for me, okay? Write the word right. In quotes, put log 1 time. So for something to be fully condensed, you only see the word log 1 time. Okay? Okay, let's write down the rules. Product. What does product have to do with? Add, subtract, multiply, or divide? Tell me. Multiply. Okay, so everybody write log base A of BC. And do you see how the BC, it gets a little complicated? So I always like to throw parentheses around it. So if they're multiplied and they're condensed, when I expand them, what do? I kind of went over it up above. What do? It's add, yeah. So it's log base A of B plus log base A of C. Quotient. What does quotient have to do with add, subtract, multiply, divide? Divide. So it's going to be log base A of B over C. Guys, do you see how I've only written the word log 1 time on the left side? That's what it has to be like. So if they're divided, what do I do when I expand them? Do you remember? You subtract, yeah? So it's going to be log base A of B minus log base A of C. The power property, this is like at least the second time, if not the third time, that this property has been introduced to you. So this is nothing new. This is log base A of B to the c power. So it's a power property because that c is an exponent, right? To expand it, you just pull it in front. So it's c times log base a of b. Okay, so you could go from the right to the left. So you can go from expanded to condensed, or you can go from condensed to expanded from the left to the right, but the rule just stays the same. Okay, let's go from example 4, expanded. What I want you to do is to put parentheses around those right there. Okay, don't do anything, and I want to ask you a question before we start. How many times right now am I going to write the word log? Tell me that. 3 times. 1 for the 2, 1 for the x, and 1 for the y, right? And those are multiplied, so when I expand, I'm going to add. So this is going to be log base 2 of 2 plus log base 2 of x plus log base 2 of y. Now, my guess is this is probably going to be a 3-point question, and if this is how you wrote it, you would lose 1. At least on my test, I would take off 1. Why is that a minus 1? Log base 2 of 2 is 1. Yeah, that's another rule. So it's 1 plus log base 2 of x plus log base 2 of y, and we're done. That's it. Okay, question B. Okay, freeze on question B. It is for sure the worst problem, the problem that people have the most trouble with. Okay, so just make it so easy, guys. Look, tell me this. How many times will I write the word log? 3 times. Some of those are going to be negatives. Can you tell me how many of them are going to be negative?
1.
It's actually 2. Because how many things do I have on the bottom? 2 things. So it's so easy. Listen how easy. Top, positive, bottom, negative, done. Like, that's how easy. So this answer is just log base 3 of 4. Minus log base 3 of x minus log base 3 of z. Those are both negative because they're on the bottom. That's your answer. Like literally not an ounce of work. Okay, now I want you to freeze and I want you to look up. Okay, please don't go on to C. I want you to look forward. Here's what people say every single time, or they think about it and they don't ask me. Okay, I don't understand this. I'm speaking like I'm the student. I don't understand this because these are multiplied right there. And multiplying means I'm supposed to add those together. So why is this not a plus? Who says, I was thinking the same thing? Anybody? Okay. So I'm going to show you, and I'm going to show you just one time. And then I want you to erase it from your memory. And I want you to say top, positive, bottom, negative, done. Easy. Okay. I want you to draw an arrow to this and write a note to yourself and say, don't make this too difficult. It's so straightforward. Okay, watch me do this, and you will understand why the z is a negative. Okay, look. Log base 3 of 4. You might even want to write this down. Log base 3 of 4 minus log base 3 of x times z. Okay, because the x times z is on the bottom. But now I have to expand the x times z, so it's going to be log base 3 of 4. But guys, see that negative? It has to be distributed to that expansion. So it's going to be log base 3 of x plus log base 3 of z. And then my next step would be to distribute the negative, and I end up with what I got immediately the other way. Okay? Who says I understand now? Okay. Top, positive, bottom, negative, done. Don't make it any more difficult than that. Okay? Okay, question C, that's actually condensed. This is a very simple problem. What do I do to expand it? Pull it down in front. Yeah. So it's just 3 times log base 2 of x, and I'm done. That's it. Okay, let's do the next one. Everybody in the room, tell me, how many times will I write the word log right here? Talk to me. 3 times. 1 for the x, 1 for the y, 1 for the z. So everybody go log base 3 of x to the third plus log base 3 of y to the second plus log base 3 of z. If this were a 3-point question, you would miss 2 of the 3 points. What do I have to do? Bring down your exponents. Yep. So this is 3 times log base 3 of x plus 2 times log base 3 of y plus log base 3 of z. That is fully expanded as far as we can get it. Raise your hand if you think this is easy. Give me a big raise up. Okay, yay, doesn't that feel good? Okay, right here. Everybody in the room, I'm actually going to make it tougher. I want you to add a p squared right there. So on the bottom, you have a z p squared. Is an ln a log? Tell me that. Yes, it is. So it's going to follow all the same rules, right? How many times will I write ln? Everybody tell me that. 4 times, right? Top positive, bottom negative. So let's go ln y squared plus ln square root of z minus ln x minus ln p squared. Take your eraser, get rid of the square root of z, get rid of that square root all around the z, and write it as a z to the, tell me what that is, 1/2. That'll save us a little bit of time. What do I do now? Everybody talk to me. Pull your exponents down. So you have 2 ln y plus 1/2 ln z minus ln x minus 2 ln p. There's my answer. Done. Okay, now we're going the other way. Literally just as easy, the exact opposite. So think of what the last thing I did on the previous problem. That's going to be the first thing that I do here. Everybody tell me what to do first. There are 35 people in this room, so I should have 35 people talking to me. What's the first thing I do? Pull those up. 35 people. Freeze right here and don't write. 35 people. What's my first step? Pull that exponent up, right? Okay, so everybody write log of x. Now, do I really want write log of x to the 1/3? No. Because then I'm going to have to write it as a cube root. So this is the log of the cube root of x plus the log of x minus 3 to the 5th. And now I'm ready to condense. When I condense, I write the word log 1 time. Those are added. So when I squish them, they're going to be what, everybody? Multiplied. Yep. So it would be the cube root of x multiplied by x minus 3 to the 5th. And that is terribly complicated. If you left it like that, I think that's crazy. Okay. You're taking the log of a ton of stuff and it's complicated. And I've already got parentheses. So the next biggest type of parenthesis would then be a bracket. So I would put brackets. If you put, parentheses or even braces, it would be fine. Brackets are what you're really supposed to put. Okay. Okay. Question B, exponents. So this is the ln of x minus 4 to the 4 minus the ln of x to the 2nd. I see a negative, which means I know I'm going to be dividing. So I'm going to make my fraction bar. The guy that's the negative goes on the bottom. So the x squared goes on the bottom. The positive goes on the top. And I'm done. I'm going to add brackets so it's clean. Literally, I'm done. Okay? I want to ask you a question. Don't change your notes. Let's just talk about it. What if this was a negative and this was a positive? How would that change my answer? What would that do? Go ahead, honey.
Would that just put the x squared on the top? The other one on the bottom?
You're exactly right. You're exactly right. It would flip-flop the inside. Yes. It doesn't matter if the negative comes first or at the middle or at the end. It doesn't matter. Negative goes on the bottom. Positive goes on the top. Who says gotcha? Let's see. Okay, great. Okay, here's question C. Pull those exponents up. So this is the log of x to the 1/2, which is just the square root of x, plus the log of y to the 4th, minus the log of 4, minus the log of p to the 6th. I see those negatives, and I know I'm going to be dividing, so I've got a fraction bar like that. Okay? The square root of x is a positive in front of the log, so I'm going to put it right there. The y to the 4th in front of the log has a positive sign. The 4 has a negative, it goes on the bottom. The p to the 6 has a negative. It goes on the bottom. Done. Logs are so easy. I swear they are. Who hated logs before we started about a week ago? Raise your hand really high. Haters. All haters, raise your hand all the way to the ceiling. Keep your hand in the air if you still hate them. Ooh, I lost some hands. It's okay. You can keep hating them. It's okay. They're kind of strange, but you can't say they're tough. I don't think they're tough. Just know the rule. Okay, here we go. Condense it. Look, guys, look right here. This is important. Look at this log base 2 of 8. Since the 8 is not a variable, like if it's a log base 2 of x, I wouldn't be saying this to you. But since it's a number, they're trying to get me to write it as log base 2 of 2. If this were a 7, could it be possible to write that as log base 2 of 2? No. But it's an 8, so it is possible. Okay? So this guy right here, I'm not going to change anything. So it's log base 2 of x minus 1 squared. This middle guy, I'm going to write minus log base 2 of 2 to the third, because 2 to the third is an 8, plus log base 2 of x plus log base 2 of 2 to the third. Well, now look what I've got. I've got a negative log base 2 of 2 to the third and a positive log base 2 of 2 to the third. Those actually just go away. So then what I have is log base 2 of x minus 1 squared plus log base 2 of x. Those are added. So when I squish them, they're going to be multiplied. So it's x times x minus 1 squared. I'm going to put brackets around it, and I'm done. That's it. Okay. We are almost done. Okay, true, false. Is that equal to that? Well, what they did, I can see what they did. They knew the negative meant divide. They divided on the right, but what did they do wrong on the right? They wrote log twice, right? And if it's condensed, you're supposed to write it just one time. So I don't know that it's for sure wrong, but it's certainly looking like it's wrong, okay? So I'm going to rewrite the left-hand side, and I'm going to write it as the log of x plus 1 over 3x. And I'll add some brackets or parentheses right there. And then the right-hand side, I'm not going to change. They don't look the same, but that's not enough to prove that they're not the same. How could I prove that they're not the same pretty easily? Does anybody have any idea? How could I do it? Say it again. Somebody said something.
Put something in for x.
You're right. Put something in for x. What's something I can't? Give me some examples of something I can't put in for x. A 0. Good. How could I do like a -5? I'd be taking the log of a negative number. Can I take the log of a negative, guys? No. So I'm going to say, let x equal 1. I can't do 0. Would be nice to do 0, so I'm going to do the next easiest with it, which is a 1. So that's going to be the log of 1 plus 1 over 3 times 1 is equal to the log of 1 plus 1 over the log of 3 times 1. Okay, now grab your calculator and let's see if you know how to do it. When I have you guys put these in the calculator, every time I teach this, I have some people who don't participate in practicing on their calculator, and then it comes to quiz day or test day and they don't know how to do it, and then they're host. Okay, everybody hit log. I know 1 plus 1 is a 2, so I'm just going to go 2. I don't hit log again, I just hit divide. 3 times 1 is a 3. Close it off, hit enter, and I get negative 0.1761. I'm going to see if I get the same thing over here. So I'm going to go the log of 2, close it off, divided by the log of, tell me what to put in, guys. It's just 3. Close it off, hit enter, and I get 0.6309. Are those equal? Nope. I'm going to change it to a not equal to, and I'm going to say it's false. If they ever ask you to justify, they just won't work. Well, we just justified it, so we're good. Okay. All right. Look at example 7. How in the world am I supposed to do that on my calculator if it's not log base 10? Now, I think we already talked about this last time, right? So what you do is you go log of 30 divided by the log of the base, which is 4. That's it. So everybody go log 30, close it off, divided by log 4, close it off. You get a bad decimal. Let's say that the directions said to round to 4 digits. So it'd be 2.4534, and I'm done. That's it. Okay, this guy right here. What one goes on top, guys? Is it log 14 or log 12 or log 2? Talk to me. 14. So it's just log 14 divided by log 2. Everybody go log 14, close it off, divided by log 2, close it off, and you get 3.8074. 4 digits. You guys, is example 8 highlighted, or 9, and 8 or 9? Say it again. Oh, we got a 10. Okay. So 8 and 9, they used to love to put these on. They must not have put it on last semester. I bet they did the semester before. So I put a star right here because although it's not highlighted, I think it still has a pretty good chance. Okay. And then I want you to write a note. And this is what I want you to put. Expand fully first. And then I just want you to look up and I want you to watch me do this. And you're going to tell me what I'm doing wrong. Okay? Look right here. Log base b of b to the second times 3.6 to the fourth over 1.2. That's wrong. Please don't say it's wrong because you didn't expand it first. That's not what I'm wanting. Why is this wrong? Lots and lots of people do this, and it's not right. You guys are so smart. Go ahead. Yes, please. Talk really loud, sweetie pie.
The 3.6 and the 1.2 still apply to log B.
What did I do? You're right. What did I do? Try to say it in like a really simple way. Look at what I did. Look at what they gave me. And tell me why that's wrong. You're right, but it's not coming out very clearly. Go ahead, bud.
You put 3.6 in for only C, not log base B.
Yeah, you're exactly right. Look, I put C is 3.6. This does not say C is 3.6. I put in 1.2 for D. This does not say D is 1.2. Who says I understand that? Okay, so don't do that. Okay, now let's follow the directions and let's expand it. I'm going to write log 3 times. Okay, so we're going to go log base B of B squared plus log base B of C to the 4 minus log base B of D. Okay, now look what people do. They'll go log base B of C is 3.6. That's 3.6 to the 4th power. Is that right? No, I didn't fully expand it. Why is that not fully expanded? What's wrong with that? Tell me. Exponents. Yeah. So that 4 is not an exponent. It's multiplied by 4 because when you pull it down, it's 4 log base B of C. Is that fully expanded? Tell me. Yes. Now I substitute in. So log base B of B is a 1. 1 times 2 is a 2. Log base B of C is 3.6. So that's 4 times 3.6. Log base B of D is 1.2. Now you just grab your calculator. So you go 2 plus 4 parenthesis 3.6, close it, minus 1.2, hit enter, and I get 15.2, and I'm done. Okay, I'm surprised that wasn't on because it's always on. Okay, let's do this. Expand it. So it's log base A of A squared plus log base A of B to the 3rd minus log base A of C to the 4th. Exponents. 2 times log base A of A plus 3 times log base A of B minus 4 times log base A of C. Now substitute. Log base A of A is a 1, 1 times 2 is a 2. Log base A of B is 1.1, fill that in. Log base A of C is 0.7. Grab your calculator. And you get 2.5. Is that what you guys got? Did anybody put that in, get 2.5? Okay, thank you. Yes, honey?
Will we get docked points if we skip the first step?
No. No, I know you guys are smart. No. Okay, right here. This was on my midterm. I think it was the first time my students had ever seen it. Like, I think it was a new problem that I'm like, great. It's really so easy. I'm so glad I put it in the notes because I think it's going to be there. Look at this right here. I'm trying to find that. Log base D of X. It's almost there, but I've got that 4. Should I divide by 4? Like, is that my first step? Divide by 4? What's my first step? Pull it down, right? So you have 4 times log base D of X is equal to 15. What do I do now? Now I divide by 4. So it's log base D of X is 15 over 4. Guess what? Done. That easy. Pull it down and divide. That's it. Okay, we're done. Anybody have any questions about anything? Okay, what would I like you to work on right now? What do you think? Your corrections. Yes. Okay.